Hello? Now let us solve the problem together. So the function g of x is equal to square root of x, and the domain of the function g, of course, is given to be this interval. So we want to show that this function g is uniformly continuous on this interval. So let me write the definition of uniform continuity first. We say that the function g, any function g, is uniformly continuous on its domain if for all epsilon greater than 0, this means for all, there exists a delta greater than 0, so that for all x and y in the domain of that function g, for every pair of x and y that I choose from the domain, if the distance between these two numbers is less than delta, then this implies that the distance between the g values here is less than that pre-assigned epsilon. Okay? So this is the definition. Someone gives you an epsilon. The constraint is that the epsilon should be positive. How big it is or how small it is doesn't matter. For any epsilon positive, you should be able to present the proof, the argument that a delta positive exists, okay? So that for every pair of x and y that you choose from the domain of the function, if the distance between those 2 points is less than delta that you offer, then it is guaranteed that the distance between the function values at those points, gx and gy, be smaller than the pre-assigned epsilon given by the first person. Okay, so in order to do that, let me translate this definition into the language here. So you see that g of x minus g of y is equal to, instead of g of x, I can write square root of x. Instead of g of y, I can write square root of y. One thing is clear, I am taking x and y distinct numbers, because if x and y are not distinct numbers, of course the difference is 0 and 0 is less than delta. But then the point is that gx and gy also become equal, and then 0 is less than epsilon is already guaranteed, so I don't need to do hard work to fine-tune delta, because for every choice of delta, 0 is less than epsilon, because the constraint for epsilon is to be greater than 0. So I am on the safe side if I assume that x and y are distinct numbers. Okay, so I want to control this value. I want to make it smaller than the pre-assigned epsilon. The only tool that I have in my hand is fine-tuning delta. So epsilon is given, is not changed during the problem. I want to fine-tune delta, which is the only thing I have in my hand to control this distance, so that if this happens, this quantity becomes less than epsilon. Okay, so it means that it is a good idea if I can connect this and that somehow, because I want to use this to make this smaller than epsilon. So one way to do that is probably easy to realize. I can multiply this by the conjugate of that expression. And of course, I have to divide by that to compensate the multiplication. The benefit of that is that when I multiply this by that, it becomes a conjugate rule, so it becomes x minus y. And in the denominator, I will have the square root of x plus the square root of y, which can be written as the absolute value of the numerator divided by the absolute value of the denominator, but x and y are chosen from this interval, so they are positive, and so this means that I don't need absolute value sign anymore here. Okay, so we realize that this expression is equal to that expression for this particular function. And you see that what happens in the numerator is exactly what is under my control. By making this delta small, I can force this quantity to be small. Okay, now I want to fine-tune delta in a way that this quantity becomes less than epsilon for all choices of x and y in the domain. Okay, so what you can see is that this is a very simple inequality that you can see, that the square root of x plus the square root of y for non-negative numbers is definitely greater than or equal to the square root of x plus y. It's very simple to prove this. For example, you can raise both sides to power 2. This becomes x plus y plus 2 times the square root of x is square root of y. And this is just x plus y. So this is clear that the left-hand side squared is greater than or equal to the right-hand side squared. And because these quantities are positive, so this is also greater than or equal to this one. But this one itself is also greater than or equal to the square root of x minus y absolute value. And that's also simple because x and y are positive. So absolute value of x minus y. So what I'm claiming that x plus y, if x and y are positive, is greater than or equal to absolute value of x minus y, which is very clear. If two numbers x and y are positive, if I add them, definitely the result is greater than if I subtract them. Okay, so if this is greater than that one, of course, square root of that one is also greater than the square root of that one. But what is the good point about this? Because if this number is greater than or equal to that number, then hopefully you agree with me, this fraction is less than, I keep the numerator as it is, but instead of that, I write this. Let us try to understand it once more. So I am comparing this fraction with that fraction. The numerators are the same, but according to this inequality, the denominator of the left-hand side fraction is greater than or equal to the denominator of the right-hand side fraction. So this means that this fraction is less than or equal to this fraction because the numerators are the same, but the denominator here is bigger than the denominator there. And of course, this can also be simplified to this one, yes? Because, for example, you can write x minus y is equal to square root of x minus y absolute value times square root of x minus y. So one of them is canceled with the denominator, and I have this one. Okay, so after doing this polishment, you see that my goal, of course, is to make this less than the pre-assigned epsilon. Okay? But I am saying that if I succeed to make this one less than epsilon, I achieve the goal, yes? Because this expression is less than or equal to this expression. So if I somehow manage to make this one less than the given epsilon, automatically this one, which is smaller than this one, also becomes smaller than epsilon. But making this smaller than epsilon is easier for me because it has a very close connection to what I can control, yes? So, in other words, what is this? I would say that epsilon is given. I want to fine-tune this delta, which is positive. I want to fine-tune this delta, if possible, so that for any pair of x and y in the domain of G, which is 0, infinity, yes, if absolute value of x minus y is less than delta, which is still I don't know, then this expression becomes less than epsilon. Of course, this is not exactly my problem. My problem is to make this one less than epsilon. By this explanation, you understand that if I make this one less than epsilon, I also achieve the goal that this is also less than epsilon. But this is extremely simple to do because this itself, from mathematical point of view, this is equivalent to saying that this is less than epsilon squared. Okay? So, I am asking you, what positive value for delta you can choose so that if this happens, it guarantees this happens. Very simple, because you see that it is enough to choose delta less than or equal to epsilon squared. But of course, because I want to have delta positive, so this should also be positive. So any delta within this range will work for me. Okay? If I choose delta somewhere between 0 and at most epsilon squared, then this guarantees that one. And if this is guaranteed, this is guaranteed. And if this is guaranteed, because of this inequality, this is also guaranteed. My goal was to prove the existence of one, at least one delta like that. I actually found infinitely many deltas. Any delta greater than 0 and at most equals to epsilon squared will work. So this means that I was able to prove that this function is uniformly continuous on the given domain. Okay, so if I want to review, someone gives me an epsilon positive, my duty is to prove the existence of a positive delta, so that for any pair chosen from this domain, this inequality guarantees this inequality. And what I did, I offered that relation for my delta. Okay, so I can say that, okay, if you give me epsilon, you are waiting for me to give you delta. I square the epsilon that you gave to me and offer it back to you as your delta. Okay? So I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.